بسم الله الرحمن الرحيم. In this lecture, we are going to speak about the variation of parameters, where we will find the solution for second order differential equation using different techniques of, or from the one that we have discussed in the last time. In the last lecture, we spoke about the finding the solution using the indeterminate of coefficients method, and the one before was using the reduction of order. For this one, which is the variation of parameters, we are going to introduce new techniques to find the solutions of differential equation. As we studied before, the solution of the homogeneous equation, if the left-hand side equal to 0, is given by yc equal to c1 y1 plus c2 y2, where c1 and c2 must be linearly independent. And the particular solution, which is part of the general solution, which is equal to yc plus yb, also must be linearly independent of the yc. The idea for the variation of parameters is to replace these constants c1 and c2 by two functions. We call them u1 of x and u2 of x. This is just to guarantee that the particular solution is linearly independent from the particular solution. Now, if we use this combination for the particular solution, y sub b equal to u1 of x y1 of x plus u2 of x y2 of x, and find the first derivative and second derivative for this one. And plug it in the differential equation, simplify it, we will have this expression. And then we will get d by dx y1 u1 plus u2 y2 plus b y1 u1 prime plus y2 u2 prime plus y1 prime u2 or u1 prime plus u2 prime and y2 prime equal to f of x. And the main idea for this method is to find the value for these two functions, u1 and u2. Since we have two unknowns or two functions to be found, we have to construct two equations. Two variables need two equations to solve. And for this one, we are going to assume that u1 or y1, u1 prime, u2, y2 prime equal to 0. And the second equation is y1 prime, u1 prime plus y2 prime, u2 prime equal to f of x. So we have system of equations. To solve this system, either by elimination or by substitution, then u1 prime can be written as w1 divided by w, which is this w is the Wronxian determinant, and u1 will be given equal to minus y2 f of x divided by w, the Wronxian, and u2 prime equal to w2 divided by 2, which is equal to y1 multiplied by f of x divided by Wronxian. This is the Wronxian is given by y1, y2, y1 prime, y2 prime, where y1 and y2 are the solutions of the homogeneous equation. W1, we just replace the first column by the right-hand side of the system, 0 and f of x, to find W1, and if we replace it by the second column, we'll have W2. Let's have some examples to find, or to use this method to find the general solution. So with that, I need to find, or to solve this given equation, I need to solve each differential equation by variation of parameters. I have y divided by plus y equal to secant x. So in the first step, I'm going to find the complementary solution. So we need to find yc. It means we need to find or to solve the homogeneous equation. By auxiliary equation, this will give me m squared plus 1 equal to 0. So m will be plus or minus I. This complex number. From this one, we can find that y1 is equal to cosine of x, because beta is equal to 1. This is alpha plus I beta, and alpha equal to 0, and beta equal to 1. So y1 will be cosine of x, and y2 will be sine of x. So I have y1 and y2. Let's find the Wronxian for this one. W equal to the determinant of y1, which is cosine of x. Derivative for cosine of x is minus sine. y2 is sine. Derivative is cosine of x. Now the determinant is equal to cosine times cosine square minus, with minus sign will give me plus sine square. So this is cosine square plus sine square of x, which is equal to 1. So y1 or u1 prime now, which is equal to, we go back to see the y1, it is y or u1 equal to y minus y2 multiplied by f of x divided by w, and y2 prime is equal to y1 f of x divided by w, or the Wronxian. So I'll have minus there, minus y2 is sine of x multiplied by f of x. F of x in my function or equation is secant of x. So multiplied by secant divided by 1. This is equal to sine, and secant is 1 over cosine, so I will have minus tangent. So u1 equal to integration of minus tangent of x dx, which is equal to the integration of minus tangent, which is equal to integration of sine over cosine dx, and this is equal to ln of cosine of x. Take cosine of x as u to be substituted by variable or t, or this is integration by substitution. I will have ln absolute value of cosine of x. This is u1. Similarly, u2, which is equal to y1 f of x divided by w, that is equal to y1 is equal to cosine multiplied by 1 over multiplied by secant of x divided by 1. But this is equal to 1, because secant is 1 over cosine. Cosine was, and cosine multiplied by 1 over cosine will give me 1. This is y2 prime. So y2 in this case, integration of 1 dx is equal to x. So now we can write the particular solution, yb, which is equal to u1 of x times y1 of x plus u2 of x, y2 of x is equal to u1, we found it to be ln of cosine x, or absolute value of x, that will be ln absolute value of cosine of x multiplied by y1, which is cosine of x, plus u2 is x multiplied by sine of x. So this is the particular solution. yb equal to ln absolute value of cosine of x multiplied by cosine of x plus x multiplied by sine of x. Let's have another example. Suppose that I have this differential equation y second derivative plus 3y prime plus 2y equal to sine e to power x, or sine of e to power x. Similarly, we need to find yc. So we need to solve that homogeneous equation by the auxiliary equation. This is m squared plus 3m plus 2 equal to 0. By factoring, this can be written as m plus 1 and m plus 2. So we have m equal to minus 1 or equal to minus 2. So y1 equal to e to power m1, which is minus x, and y2 equal to e to power minus 2x. So by this, let's find the Gaussian. Gaussian equal to y1 e to power minus x. Now the derivative for this one is minus e to power minus x. y2 e to power minus 2x. Now the derivative is minus 2 e to power minus 2x. This will give me minus 2 e to power minus 3x. Minus minus will be plus e to power minus 3x, which is equal to minus e to power minus 3x. So this is the Gaussian, e to power minus 3x. Now let's find u1 prime and u2 prime. u1 prime equal to minus y2 f of x divided by function, which is equal to minus e to power minus 2x multiplied by f of x. f of x is sine e to power x divided by function, which is minus e to power minus 3x. Simplify it. I will have e to power x, but this will go with this one. So I will have e to power x multiplied by sine of x. And if we integrate this one to find u1, I will have integration of e to power x sine e to power x dx will give me minus cosine of e to power x. This is u1. u2, which is equal to y1 f of x multiplied by w. y1 is e to power minus x multiplied by sine of e to power x divided by minus e to power minus 3x. This one, this is again y2 or u2 prime. It will be minus e to power 2x multiplied by sine e to power x. Now to find the u2, we integrate this one. It will be minus e to power 2x sine e to power x dx. This is by substitution, but t equal to e to power x. Then dt equal to e to power x dx. Use this one. We will have u2 equal negative. Let's take it one by one. So dx from this one will give me dt by e to power x, or it is dt by t. So the integration now, u2 will be negative integration of t squared sine of t dt over t, because I have e to power 2x, which is this will be t to power 2. So it can be simplified to be t multiplied by sine of t d. And this can be done by integration by part. I have t and we have sine of t. Derivative is given 1, just differentiate and integrate. I have minus cosine of t, 0, then we'll have minus sine of t. Plus and minus. So the integration for this one will be minus of the bracket. The first one is minus t cosine of t, and then plus sine of t, which is will be can be written as plus t is e to power x multiplied by cosine of e to power x plus sine e to power x. This is u2. So the particular solution now yb, which is equal to u1 y1 plus u2 y2 is equal to u1. We say this is equal to, go back to see it. It is minus cosine e to power x. So it is minus cosine e to power x multiplied by y1, which is e to power minus x, plus u2, which is this one, e to power x cosine e to power x plus sine e to power x multiplied by e to power minus 2x. So this is the particular solution for the given differential equation. So the idea for this technique, which is variation of parameters, we need to find the particular solution, then use it to find the particular solution. This will overcome the limits already shown in the indeterminate coefficient or the other one. Because for the indeterminate coefficient, we need to know specific form of g of x so that we can use the indeterminate coefficient, differentiate, and find a constant. This will be more useful.